Today we're going to look at simultaneous equations. Now this is a concept that we did last year in Form 3. We taught you two methods last year. We taught you to substitute in a value, and we also taught you to eliminate one of the values. Now this year we need to focus on the method of substitution. So I've got two equations. I've got y is equal to x minus 1, and I've got xy is equal to 4 plus 2x. In my first equation, I've got y on its own, and that y is equal to x minus 1. So the first thing I'm going to do is where I see y in the second equation, I'm just going to replace it with x minus 1 instead. So the first thing we're going to do is substitute equation 1 into equation 2, which means you end up with x times x minus 1, because that y I've just replaced with x minus 1, is equal to 4 plus 2x. If I multiply my x into the brackets, I end up with x squared minus x is equal to 4 plus 2x. And now we're just dealing with a simple quadratic equation. We need to get everything to one side and make the equation equal to 0. So we end up with x squared minus 3x minus 4 is equal to 0, which we can factorize to x minus 4 and x plus 1, and solve the equation, and I get two answers for x. I get x is equal to 4 and x is equal to minus 1. But we also asked to solve for y simultaneously, so we're going to go back to equation 1, which is y equals x minus 1, and we're just going to substitute our x's back into this equation. So y is equal to 4 minus 1, so y is equal to 3, or y is equal to minus 1, so y is equal to minus 2. So I get two answers for x and two answers for y. Pause the video now so that you can make some notes. Let's try a second example. In this example, I've got 3y plus x is equal to 2, and I've got y squared plus x equals xy plus y as my second equation. Now this one is a little bit more difficult because I don't have x or y on its own. But if I take the first equation and I just take 3y over to the other side, it's easy enough to get x on its own. So that's your first step. So make sure you can get either x or y on its own. You want to avoid fractions at all costs though. So this time it's best to get x on its own. And now I've got equation 1 and equation 2. Now in this equation, every time we see an x in the second equation, we're going to replace that x with 2 minus 3y. So we're going to substitute equation 1 into equation 2. And we end up with y squared plus 2 minus 3y is equal to, in brackets, 2 minus 3y times y plus y. I just need to multiply this y into the brackets on the right-hand side. And we end up with y squared plus 2 minus 3y is equal to 2y minus 3y squared plus y. You need to get your trinomial and make your equation equal to 0. We end up with 4y squared minus 6y plus 2 is equal to 0. Now remember, you have got the quadratic formula that you can use, but if you can make the equation easier to solve and just factorize it normally, that's a much better idea. So in this equation, I can divide everything by 2, making it 2y squared minus 3y plus 1 equals 0. And then it's not too difficult to factorize, but you can use your formula if you prefer. It factorizes quite easily to 2y minus 1 and y minus 1. And the answers to those brackets would be y is equal to a half and y equals 1. But now we asked to solve for x and y simultaneously, so we're going to go back to equation 1 and substitute both y values into that equation. So in the first one, we get x is equal to 2 minus 3 times a half, so x is equal to a half, or x is equal to 2 minus 3 times 1, so x is equal to minus 1. Pause now so that you can make some notes. Thanks for watching Max Maths. If you liked what you saw, please like, share and subscribe.